Let's look at 1/2 x to the 4th minus 2/3 x cubed minus 2x squared plus 3 on the interval from -2 to 3 and determine the absolute max and absolute min of this function. So 2 steps, find the critical numbers. So I'm going to take the derivative and set it equal to 0 to find any critical numbers. I'm going to bring down the power. I have half of 4. Half of 4 is 2, x cubed. Bring down the power 3. I'd have -2/3 times 3, which would just be -2, x squared. You can always use a calculator. Then I have -2 times 2, which is going to be -4x. And then the derivative of 3 is 0. It's a constant. So I'm taking my derivative, and I'm going to set it equal to 0 and see if I can factor anything out. Well, I definitely have a greatest common factor here. I can pull out 2. 2 goes into all the terms, and then the least power of x is x. So biggest number and least power of x are what you'll pull out every time for greatest common factor. So 2x times x squared would give me my first term. And then 2x times -x would give me a -2x squared. And 2x times a -2 would give me -4x. I want to set that equal to 0. I can continue factoring this derivative, so I'm going to keep going. I want to multiply to be a -2 and add up to be a -1. So to multiply to be a negative, I must have a positive times a negative. And I want to choose factors of 2 that differ by 1, and so that they'll add up to be a -1. So I want to make sure the bigger number is the -1, so that they add up to be a negative. Well, 2 is prime, so it's only 1 times 2. So +1 times -2 is going to give me a -2, and then 1 minus 2 will give me the -1 as my x term. So I know 3 things can only multiply to be 0 as long as one of the factors is 0. So I want to see if I can make 2x equals 0, if I can make x plus 1 equals 0, or if I can make x minus 2 equals 0. So 2 times something is 0. Well, I could divide both sides by 2. 0 divided by 2 is just 0. Or you might know 2 times something is 0, that something must be 0. If I subtract 1 here, I would get x equals -1 for my second critical number. And then I'm going to add 2 here, and I get x equals +2 as my last critical number. So we have 3 critical numbers, which is kind of a bummer. The more critical numbers, the more work, because we have to plug in and find their y values. But remember, you only have to test critical numbers if they're on your interval of interest. So maybe some of these are not, because our second step is if we have endpoints, we are going to compare those endpoints to any critical number in between. So we are looking from -2 to 3. So is 0 on this interval of interest? Yes. So I'm going to have to test that. Is -1 between -2 and 3? Yes. Is +2 between -2 and 3? Also yes. So I have to test all of these numbers. So I'm going to plug them all in. I'm going to have f of -1, f of 0, and f of 2. Order doesn't really matter, but I like to put them from smallest number to biggest number. So now I need to plug into the original function a whole bunch of times. So I'm going to grab my calculator, and I'm plugging into these. Feel free to pause the video and plug in and check your answers. So first thing, plugging in -2 into the original function for the y value, I'm getting 8.3 repeating. If I plug in -1, I'm getting 2.16, the 6 repeating. F of 0 is 3. F of 2 is -2.3 repeating. And lastly, f of 3 is 7.5. So lots of y values to compare. And I want to pick out what is the absolute max and what is the absolute min. So first of all, what's the highest number between 8.3, 2.16, 3, -2.3, and 7.5? Definitely 8.3. So our absolute max value would just be 8.3 repeating. Our absolute max point would be writing as -2, 8.3 repeating. And then looking for the absolute min, well, there's only one negative number on here. It's negative 2.3 repeating as my y value. So that must be the absolute min value is negative 2.3 repeating, or as a point, it would be 2 comma negative 2.3 repeating. And you could definitely make these fractions since they are repeating decimals. That would be great for an exact answer. I just like to compare while they're decimals because I think it's easier to pick the highest and lowest y value that way, but then you can always switch them back to be fractions to get an exact answer.